Morning, everyone. Rain is pouring and the wind is howling in Laguna, Philippines, but it is still a beautiful day to learn something new together. Welcome to the 35th SEARCA Online Learning and Virtual Engagement or SOLVE webinar. We are streaming to you live through Zoom and Facebook Live. This morning, together with the USDA Foreign Agricultural Service U.S. Embassy Manila and the International Service for the Acquisition of Agri-Biotech Applications, we will try to solve public info-sufficiency on genome-edited crops. My name is Jerome Baradas from SEARCA's Research and Thought Leadership Department. I will be your moderator for this morning's webinar. So if you are joining us through Facebook Live or through Zoom, just comment OK or ready so that we'll know that you are game, that you are G to join us this morning. To open today's learning session, may I call on Morgan Haas, Agricultural Counselor of the USDA Foreign Agricultural Service, for his opening message. Morgan?
Thank you very much, Jerome, and thank you for everybody joining us here virtually on the platform of your choice. It's a true pleasure to be able to talk to the public and have your engagement on this, because ultimately, at the end of the day, the consumer is always right, and we need to be producing things for what the consumer needs. So what we're doing as well is we're trying to battle through a number of challenges along the way to lead us into that future. Certainly, many of you are aware of the many crises facing the world today, including the Philippines, whether it's COVID or climate change, whatever it is. I think we can all agree that science and technological innovation is leading the way for those future solutions that we've adapted and adopted. Certainly, I get to read about them, and I've learned very much in both the science and technological aspects of everything that's been done in both of those areas over the last years or years now. But unfortunately, we don't always have that same opportunity to get that same level of outreach to let everybody know all the great things that are happening in the food and agricultural space to helping greatly ensure your food security from now on in the future. This is a topic that has been, though, generating a lot of interest over the last year, particularly given the strong connections in particular with food security and climate change. It's a topic that's picked up a lot of steam here in the Philippines, as you've readied and done some national meetings in preparation for the UN Food Systems Summit, as well as the COP26 meeting taking place later this year on climate. What we're talking about here is all the interrelated dynamics between climate and food security, and how we're going to feed a growing population here in the Philippines and across the world. And certainly having to do so on still a very limited amount of land to grow and produce food. So what we're talking about is advancing these SDGs, the Sustainable Development Goals of the UN. Number one, looking at battling zero hunger, malnutrition, problems here and across the world. We're also looking at trying to more greatly ensure farmer prosperity through reducing agricultural footprint by increasing their yields and being able to stop these persistent pests and diseases that have continued to precipitate, as well as climate change. Certainly, the Philippines had to battle that. You face that as well with items like African swine fever, avian influenza that have continued to plague this country for some time. So, again, I'll end it here. But otherwise, thank you for joining us and continue to embrace science and technology innovations, just as we have in COVID, climate. Food is no different. So back to you, Jerome.
Thank you, Morgan. The short video shown earlier has given you a glimpse about what SEARCA is doing. SEARCA is hosted by the Philippine government inside the campus of the University of the Philippines, Los Baños. The SOLVE webinars aim to provide an avenue for knowledge sharing on concrete, innovative actions on the ground along SEARCA's 11th five-year plan via technology-mediated social platforms that would directly benefit farmers and farming families, as well as engage the youth in agricultural and rural development. Launched in April 2020, the Solve webinars use popular online platforms like Zoom and Facebook and are live streamed to interested audiences anywhere in the world. Before we proceed to our online conversation this morning, please allow me to quickly go over some interesting statistics gathered from this last Solve webinar held last August 11, and it was about promoting youth inclusion and innovation. In the infograph that we'll be showing you, you will see that majority of our online participants were female. It also showed that around 143 participants tuned in via Zoom, while almost 300 were following the discussion through SEARCA's Facebook page. We are also happy to note that we've had online attendees not just from the Philippines, but also from Cambodia, Indonesia, Myanmar, Thailand, and the United States. Allow me to show you this morning's program and read you some reminders. Our first speaker will be talking about genome-edited crops, status, policies, and potentials. And then we'll have our second session with Saturnina Halos on gene editing in the Philippines, opportunities and constraints. This will be followed by the open forum and a closing message from our director, Dr. Glenn B. Gregorio. For those of you who are tuned in via SEARCA's Facebook page, you may type your questions in the comment section. Kindly indicate your location and our country of origin. If you are tuned in via Zoom, please post your questions or comments in the Q&A box, which you would find in the menu bar on your screen. Kindly indicate your location and our country of origin as well. So this is how we know where you are in our documentation. I will verbally convey your questions to our speakers, and hopefully we will be able to cover as many as we can in the time remaining. Please be clear when you are posing a question to a specific presenter, or if it is a general question that anybody can respond to. We will do our best to get as many questions as possible during the open forum. Please know that you may already post questions while the presentations are going on. Please note also that this webinar is being recorded and will be made available on SEARCA's Facebook page and YouTube channel. Today's presentations will also be available on SEARCA's website at www.searca.org, and the slides shown during the past Solve webinars have already been posted there. For your social media posts, especially on insights or takeaways from this webinar, please use the hashtag SEARCASolve. So you may share this webinar as well to your friends and classmates who might find this session interesting. If you have issues or are experiencing technical difficulties with the Zoom online platform, please contact us at solve@searca.org. Before we begin today's learning session, please let us know again if you are already ready by typing the words GAME on the comment section. You may also type in your location so that we'll know where you are joining us from. Please avoid commenting your email addresses in the comment section. Okay, we have an active group here, and we are thrilled to have you and see a lot of people typing GAME. So that's my go signal. We begin our learning session for this morning. Our first speaker is Dr. Carl Ramage. Carl is the chair of the Institutional Biosafety Committee of La Trobe University, Australia, and the managing director of Rautaki Solutions, a business that supports national and international ag biotech organizations across public and private sectors. He focuses on providing strategic and operational direction in biosafety and biorisk management. Carl also sits on several agriculture industry committees, including institutional biosafety committees, and is the current appointed chair of the Trobe University Institutional Biosafety Committee. He is a board member of the Association for Biosafety Australia and New Zealand and a member of the Australian Institute of Company Directors. Dear friends, let us welcome Dr. Carl Ramage. Carl, the floor is yours.
Thanks, Jerome. I'm game. I'm ready to go. Okay, good morning, everybody. I hope you're safe and well and avoiding the typhoon that seems to be making its way through the Philippines at the moment. Certainly no better introduction to climate variability or climate change than to be hunkered down trying to avoid getting wet and blown away. Look, it's a great opportunity and a privilege for me to be able to talk with you this morning and talk about something that's dear to my heart, and that's agricultural biotechnology. This morning, I'm going to cover one specific small aspect of ag biotech, genome-edited crops, and we'll embark on a little journey, and hopefully that stimulates a bit of discussion and some questions for you, and hopefully we learn something together along the way. I'm based here in Melbourne, Australia. It's actually a beautiful sunny day here. No rain, no typhoon, but we're in our 6th lockdown associated with COVID. So doesn't matter where you are in the world, we're all faced with some difficult challenges. But wherever you are, I hope you're safe and well, and I look forward to working with you this morning. Over the past 24 years, genetically modified crops have been and a growing feature of the agricultural landscape across the world. In fact, more than 2.7 billion hectares of cumulative growth area have been put to genetically modified crops or products of agricultural biotechnology around the world. And data from from ISA for 2019 shows that the 4 dominant GM crops are grown around the world. Soybean, over 90 million hectares were grown. For maize, more than 60 million. For cotton, more than 25 million. And canola, more than 10 million hectares. That's vast areas of land that have been put to genetically modified crops over those through that year. And that 2.7 billion hectares represents about the area of the landmass of Denmark. So not a small landmass that has been used for this technology. And the 2 main traits that have been modified in those 4 crops are largely there to address some significant productivity issues in agriculture, namely insect pests and weeds. And the outcomes from the use of those agricultural products is that there have been more than 24 years of benefits. And those benefits sort of target some of those things that SEARCA's very passionate about, and that's things like food security through the increase of yields, the socioeconomic benefits, increasing farmer income and creating new opportunities and improved life, and ultimately environmental benefits associated with reductions in greenhouse gases, less pesticides being applied on farm, etc. So these are demonstrated benefits from the use of only pretty much 4 crops over the last 20 years. And the term biotechnology, the genetic modification of those crops is just one small part of that toolbox that's available. So here we can see genetic transformation of wheat, a process that some of you might have tried in your classes in terms of doing plant tissue culture and trying to modify plants. But equally over the last 10 to 15 years in particular, the sequencing of genomes and sequencing information has become quite cheap, and vast amounts of data have been gathered. There is a lot of work going on to characterize plants through and phenotyping them, and phenomics has become a large area of ag biotech in its own right. And then the combination of phenotype and genotype to predict genomic predictions around new varieties, and it has become an integral part of plant breeding over the last 5 years. But now there's this new technology that has also come to the fore, and pretty much every day we're seeing articles in the newspaper around the use of gene editing or genome editing to improve a crop or improve animal welfare or contribute to biomedicine. Genome editing is essentially, in its simplest form, we're talking about some form of nuclease, a protein that can specifically cut DNA in a targeted manner. And over the last sort of 15 years, these have been developed in a way where we now have these enzymes or these nucleases that have an incredible amount of specificity and activity. So it's a bit like the invention of the telephone migrating to a mobile phone. What genome editing is, as I said, these enzymes specifically target an area of the DNA and make a cut. And that's pretty much what CRISPR does, it's what Talon does, it's what zinc fingers do. Once that cut has been achieved, there are essentially two pathways that can be undertaken. One is you let the DNA self-repair, and sometimes that includes a mutation or some sort of change, or it could be a desired outcome, to knock a gene out, for example. And we refer to that as site-directed nuclease 1, or through this NEHJ term, or non-homologous end joining. Lots of big words that scientists like to use to describe a fairly simple pathway. On the other side, we might want to actually guide the repair by providing a set of instructions. And through a term called homologous recombination, we're able to guide the repair or the change here to be something specific. And that could be just a couple of base pairs, or we might actually insert a whole new gene cassette and create a genetically modified organism. So essentially, genome editing has two pathways. It's pretty simple. You cut the DNA in a specific place and then try to make some sort of change that has a desirable outcome for you. But it gets more complicated because genome editing over the last 5 years is not just about editing the genome and making a cut. We can also use it to change the regulation of genes. We can look at epigenetic changes. We can just change one base very, very specifically. We can target RNA. We can change the structure of the DNA as well. So now there's a toolbox associated with genome editing, and that's really important. Context of then making a genome edited plant, what does that mean? What we do is we're essentially combining all of those omics, the genomics, the phenomics, the proteomics and metabolomics, all those fancy bits of information that we can gather around our plants. We can then identify specific targets and then use one of these options, one of these editing options, and then combine that with plant cell tissue culture and some form of genetic modification technique to deliver that editing opportunity. We regenerate our plants, and then we select and verify the genotype and phenotype. And that's essentially the pathway for generating a gene-edited plant. There are a range of tools to do the edit. There are a range of tools to deliver that editing machinery. And then there's a lot of work that can be done to select and verify the product at the end of it. What does that mean practically? Well, we've got a number of products already on the market that have been genome edited. For example, there is a soybean that has been modified to have a high level of oleic acid in the oil. And that's oleic acid is omega-9, so it has a human health benefit. There have been tomatoes now released in Japan that have been modified using genome editing to that provides a human health benefit by lowering blood pressure, for example. And in the US, there is a corn, a maize that has been modified using CRISPR to delete a big chunk of DNA out of a gene such that the starch composition changes from being a combination of a amylopectin and amylose to primarily being a amylopectin. And so by knocking out this one gene, we end up with a product which has favorable properties for food and industrial purposes. So we're already starting to see some products coming through to add to those GM products that I talked about in the first slide. There are also a range of other examples making their way to the market. So for example, canola that has been modified to increase oil content. We've got changes in soybeans, as I mentioned before. We've got things happening with wheat to try to change some of the properties to make it healthier. You might be interested in some of the genome editing opportunities in rice, where they're looking at introducing herbicide tolerance and some disease resistance. And in products like cassava, making cyanide free, so making them cyanide free, so improving the quality of that product. There are also a range of genome editing activities occurring in livestock, primarily towards addressing things like disease resistance and animal welfare issues. So we're starting to see genome editing being applied to a range of crops, and some of those crops being a bit beyond those 4 that I showed earlier. If we just look at what's happening in the US, so in the United States, there are you can seek a determination as to whether your product is regulated or not. And if we just focus on grain crops, we can see that through 2020, there have been a lot of products put forward to the regulator to say, am I regulated or not? And all of these products are not considered a genetic modification. They're genome edited, and you can see here maize, you can see canola, you can see soybean, and you can see barley. All of these products have been determined to have followed a particular pathway of genome editing, and you can see here SDN2, the use of a template to guide a specific repair. SDN1, where the DNA was allowed to rejoin itself, and then a different technique called ODM, or oligonucleotide directed mutagenesis, another form of genome editing tool. But what I find really interesting about this list is this column here, the companies. So the 4 main GM crops have largely been produced and commercialized by a very small number of agricultural companies. But if you have a look at this list, you can start to see that there is a change in the companies that are bringing these products to market. Some are public sector and some are private sector small spin-offs. And I think that's a real transformation that we're starting to see in the introduction of gene technologies and biotech to the agriculture sector. There are many, many, many more targets and opportunities that are being put forward virtually on a daily basis. And there are a number of publications that you can refer to see the sorts of genome editing targets that have been identified, that have been shown through proof of concept, and potentially could lead to a commercial product down the track. Not all of them are in those 4 main crops. We're starting to see things in things like potato and sugarcane, rice. We're seeing things in horticultural crops such as the tomato in Japan, grapefruits, cucumbers, mushrooms, etc. So this is a real game changer for the agricultural sector. But how do we know if these products are safe? And this is a question that the public demands of our regulators. It's something that they demand of us as scientists. How do we know? What we do know is that when we talk about biosafety or biological safety, we're talking about how do we know that a product is safe for the health of people, animals, or the environment. And we know that there are a range of products out there, biological organisms that can cause harm to us or the environment, whether it be a virus that causes a pandemic, a mosquito that causes disease in humans, plants that give an allergic reaction, or animals that might cause us harm. Then there's some potential uncertainty around the modification of some of our crops. So how do we deal with that? How do we know whether they're safe? Well, over the last 20 plus years, we've developed a range of international standards and practices for being able to assess the safety to us and the environment of biological uncertainty around the modification of crops. And so these have provided us with a platform to be able to ensure that the food that we eat and the crops that we grow are safe. So when it comes to genome editing, how are we tackling that issue? How do we know that the genome editing products are as safe as the ones that we conventionally grow or the GM products that have been developed? Should they be treated the same? What we find has happened over the last 10 years or so is that we've started to look at this issue. And in South America, they have put forward this little bit of a decision tree on whether a genome edited product should be regulated or not. And what it starts off with, which is really, really important when we look at biosafety, is early consultation with those that understand biological safety. And in Argentina, what they proposed is does the product have a new combination of genetic material? So does that genome edit create something that's novel, something that's different, something that wasn't there before? And that particular step there is really critical. And it aligns with one of the international conventions, or the Cartagena Protocol on Biosafety, which provides a definition of a GMO, or a living modified organism. And it centers around this new combination of genetic material. So if there is a new combination, it's regulated as a GMO, and we have those international standards and conventions to be able to assess its safety. And in many cases, that may then also lead to a commercial product. But if it doesn't have a new combination of genetic material, there's another question. Does the breeding method use a transgene temporarily? So does that process, the process of genome editing, use some form of transgene? And if it does, then is that in the final product? Sorry, is the final product free of that transgene? If it's not, you regulate it as a GMO. If it doesn't contain the transgene, then it's no longer subject to regulation. Similarly, if no transgene is used temporarily, it's not considered a GMO, and it dovetails into the conventional breeding program. Quite an elegant decision tree on how to tackle something that's a very complex issue. In the United States, quite a different regulatory system, in the sense that they don't specifically have a biosafety regulation act or piece of legislation per se. They use existing legislation to tackle this issue. If we just take a look at the right-hand side here, because we're focusing on crops, let's say we've got a genome-edited product, and we're going to ask the question, is this product regulated? And the very first question, so there's a consultation with the USDA, and the question comes, is this variety could not have been developed through traditional breeding, or is the plant is a plant pest, or was developed using a plant pest? So very much looking at this issue of whether it's a plant pest or not. So if the variety could not have been developed through traditional breeding, or the plant pest is involved, then it's subjected to regulation. But if it doesn't, then it's not. And so that's that list that I showed you. A lot of developers are making sure that they understand this pathway and ensure that they can provide details to the USDA to be able to provide a determination on whether their product should be regulated or not. Quite again, an elegant little decision tree. What else is happening around the world in the space of how do we regulate or ensure that these products are safe? We talked about the USA. In Canada, the issue relates to whether the product is novel. So they regulate the product, not the process of genome editing. As we talked about, South America uses the Cartagena Protocol definition and a decision tree on whether something should be regulated or not. You know what you're doing here, and we'll hear from Professor Halos about what's happening in the Philippines. In New Zealand and in Europe, they have very clearly stipulated that genome editing of crops is considered a GMO and will be regulated as such. In Australia, we're a little bit on the fence. We're still working through revision of our legislation, but one part of it stipulates that one form of genome editing doesn't require approval or an assessment for cultivation, but we still may require it for other forms of genome editing. And for a food safety assessment, we're still unsure whether some products may actually require an assessment by our food regulator. But as you can see, there's a lot happening around the world. There are a lot of countries where discussion is ongoing, and some countries have already made some determination as to whether they are where they sit. And we'll hear more about what's happening in the Philippines shortly. But the challenge for regulators is this issue of whether we regulate the product or the process. So here's an example. We take this high oleic soybean that I talked about earlier. There is a commercial product using genetic modification to silence a particular fatty acid gene in the fatty acid pathway that leads to high oleic soybean. And this is already on the market. And that uses quite clearly a genetic modification and is regulated as such. However, we can achieve the same outcome, the same product using genome editing. And that genome editing process could be using either one of these pathways. And it could be using a CRISPR, it could be using a TALEN or some other form of genome editing machinery. So should this be regulated based on the process? The products are the same. How does a regulator deal with this? This is a big challenge for regulators. So what we're seeing with genome editing is that we are seeing an evolution of the mobile phone, the genome editing technology, to evolve like your phone. Every year there's a new model coming out with new features. New targets are being identified. New methods and opportunities and options for genome editing are becoming available. We have new delivery systems. And not just one target, but multiple targets being identified to tackle some of the complex traits. So this makes it really, really challenging, again, because the technology is moving much, much faster than the regulatory systems. Importantly, though, the genome editing is just another tool. It is a tool, a biotech tool that can be used to support sustainable production on farm. And so some of the targets that we are seeing being identified in the literature are really geared towards tackling some of these climate change challenges, such as extended drought, and the lack of water. How do we sustainably feed the world and the increasing population? But on top of that, we're starting to see a greater shift from productivity traits on farm to demand from consumers for particular products. So whilst we've got a genetic modification to a salmon to produce sustainably with fast growth rates, a salmon product, we're seeing genome editing being used to tackle animal welfare issues, such as whether the animals have horns or not. We're starting to see products where they're novel in terms of, for example, a pink pineapple. And we're seeing some practical applications, such as mushrooms and apples and potatoes, where they don't oxidize and go brown. So we've got less waste. Less wastage of those products, longer shelf lives, etc. So we're seeing the consumers demand products, and that's helping to drive some of this technology and its applications to commercialization. So my concluding remarks, and hopefully to stimulate some discussion with you, is this. There are numerous genetically modified and genome edited targets that have been identified and characterized, and GM products have been around and on the market for more than 20 years. There are a number of horticulture and broadacre crops that are commercially available using both GM and genome editing, and we're starting to see more of those come to the market as regulatory systems become more mature. There are some significant opportunities for improved on-farm sustainability to tackle the challenges of climate change, as well as products with human health benefits, such as the tomato in Japan that is now being commercialized. But that commercialization, the translation from what we do in the laboratory and in our research institutes towards the commercialization and on-farm change and consumer benefit and farmer benefit is highly dependent on several things. But importantly, there needs to be a clear pathway to market. There has to be a value capture model for the development of that product. And ultimately, there needs to be some clarity around the regulatory requirements to ensure that it's safe. And we need those regulatory systems around the world to be harmonized to ensure that we can maintain free trade of those products around the world. So with that, Jerome, I will say thank you. Thank you for the opportunity to present to you. And I welcome some discussion and questions from the audience a little bit later. Thank you.
Thank you very much, Carl. We're ahead of schedule, and that means more time for us to have an engaging discussion later during the open forum. Again, I would like to encourage everyone joining us from Zoom and Facebook to post your questions. For Carl, if you are joining us through Zoom, please use the Q&A box. And if you're joining from Facebook, please use the comment section. We'll be collecting your questions, and we'll try to answer all of them later during the open forum. So let's look forward and let's have an engaging discussion later on. So if Carl gave us an international or global perspective, our next speaker, Dr. Saturnina Halos, will give us a background on what's happening here in the Philippines, back home. Dr. Nina Halos is considered as one of the pillars of Philippine biotechnology. Dr. Halos helped craft biosafety policies of the Philippines, including the first national biosafety policy, which was Executive Order 430, series of 1990. The Basic Policy on GM Crop Regulation, the DA Order number 8, series of 2002, and others. Dr. Halos also established the first functional forensic DNA laboratory in the Philippines and is also instrumental in the acceptance of DNA evidence by the Philippine Supreme Court in 2001. She is a former professor in molecular biology and biotechnology at the University of the Philippines, Diliman, and has held various academic and scientific positions in other institutions. She is presently the president and chair of the board of directors of the Biotechnology Coalition of the Philippines and serves as one of the consultants in capacity building in biotech regulation, biotechnology program office, Department of Agriculture. Getting there. Without further ado, let us welcome Dr. Nina Halos. Ma'am?
Thank you, Jerome. That's too long. Good morning from the Philippines. And for those on the other side of the world, good afternoon, good evening. So let's talk about how we understand gene editing in the Philippines and how, whether we're taking some of the advantages there that we could use and what are keeping us from adapting or using gene editing. Okay, so we'll talk about our own definition, the opportunities that we have, our constraints, and yeah, that would be it. Our constraints. Okay, gene editing, as we define it here, it is a targeted mutagenesis. You are changing a specific site in a very specific gene. So let's limit our discussion there. Carl has discussed the whole genome editing actually picture. So I'm only taking one part of that, which would be the editing or the changing of a small segment of a particular gene. And what is used here are molecular reagents that are designed to change a particular part in a particular gene. And, mutation is a change in the DNA. It may involve or this would be a mutation that involves a change in the DNA. That could be a deletion of a base pair, the insertion of a base pair, the substitution of one base pair with another. Although in other discussions, it has been also forwarded that we can have changes in few base pairs. And the molecular reagents that are commonly used are SDNs or site-directed nucleases. These are enzymes that are directed to a particular site in the DNA by their own molecular structure or by short RNA segments. So that once they're there, then they cut a particular site. And we see gene editing as an extraordinary method of altering genes in an efficient and cost-effective way. Unlike genetic modification or genetic engineering, genetic engineering involves too many processes, and also the regulation is quite onerous. So basically, there could be three components of gene editing. You have a recognition element, which could be, as I have said, a small guide RNA or a part of the enzyme itself, the nuclease or the enzyme cutting, DNA cutting enzyme. And then, of course, your cutting tool, which would be your nuclease, and a DNA fragment to introduce the side chains, or the side chains. The chains could simply be the repair mechanism of the cell, so that the result would be a deletion of a base pair, replacement of a base pair, and addition of a base pair or a few base pairs. And there are three methods of delivering gene editing reagents. One involves tissue culture here in A, and the other one would not involve. This is fully developed already, this process of using tissue culture in the delivery of the gene editing reagents. B in here does not involve tissue culture. This is you induce the plant to produce new shoots, and by delivering a developmental regulator and the gene editing reagents together, the new shoots may contain the mutation that you like. But this one is not fully developed yet for all crops. I read one or two articles about this one. And then the other one would be you use a transgenic plant that expresses the enzyme cutting protein. And then you introduce into this plant this small guide DNA, and you can produce several types of mutations depending upon the small guide DNA that you have introduced. So again, this one is not as fully developed yet compared with A, procedure A. Now, mutagenesis is a naturally occurring process, or it could be induced. Okay, we have naturally occurring, we can find it in nature. In the Philippines, we have makapuno. This is a mutation that involves the meat of the coconut. The meat of the coconut is not firm, it's very, very soft, and we call it makapuno because it fills the whole cavity of the coconut. And then, of course, we have albinos. We have the white carabao, or people who are not fully pigmented, and they're very sensitive to light. Induced or conventional mutagenesis, we use chemicals or irradiation. This has been a conventional method of breeding. We call it, mutagenesis breeding, because, in breeding, you would like to have different varieties, variation in the genome, which could be the source of the desirable trait that you would like to have. Unfortunately, when you use these chemicals or irradiation, they would make random multiple changes, and this would involve extensive long-term selection. If you remember in my previous slide, I'm talking about, a very specific change in a particular part of the gene. So in gene editing, you have a very targeted gene in mind. And of course, this now is helped by the fact that many of the genomes of the crops have been sequenced, and many of the genes that we are interested in have also been sequenced. And that makes gene editing possible, these very specific changes in the DNA. However, if you look at conventional mutagenesis, and has been used for such a long time already, about a century already. And there are more than 3,000 varieties of plants in the world market that are derived from conventional mutagenesis, such as, in China, these are the recent ones, rice cultivars. There are 2 rice cultivars that are example here from China. You have this disease-resistant nashi pear in Japan, and 2 grapefruit varieties in the USA. But there are more, I just thought I should give you some examples. And for those of you who are living in those countries, you may find these varieties in the market. Well, we think it is an opportunity for us that the regulation issue for gene-edited crops have already been resolved by the National Committee on Biosafety of the Philippines. They have a resolution that says that, we have to determine whether the product of a gene editing, or what we refer to as plant breeding innovations, would produce a genetically modified, or in the Cartagena Protocol term, LMO, or living modified organism, or not. Because our regulation on modern biotechnology is based on the Cartagena Protocol, and our regulated article are specific only to GMOs or LMOs. So that if your gene-edited plant is not an LMO, it does not contain a new gene or a new combination of genetic material that cannot be derived by traditional breeding, then it is not regulated under our existing regulation for modern biotechnology. And our farmers, they really are very excited when there are new varieties or new breeds of livestock or new strain of fishes, and they really seek for these new varieties or new strains. Okay, so it's really a preferred technology by our farmers, and that is also true with the introduction of genetically modified corn in the Philippines, the adoption of that particular of those varieties containing introduced genetic materials like BT and herbicide tolerance. The adoption rate is very, very high. From in 10 years, the area that is usually covered by hybrid corn has been totally dominated by genetically modified corn. Okay. Well, I cannot talk about, for all of the corn farmers, because in the Philippines, there are 3 types of corn that are adopted. We have the traditional, the introduced variety during the Spanish times. So that's centuries old variety. And then we have open pollinated varieties that are developed by our public sector research institutions. And then, of course, we have the GM corn, but the fastest adopted variety was GM corn. So also, the molecular breeding area using gene editing is a priority research area of the Department of Agriculture Biotechnology program, and we do provide funds for this. Okay. So, and also, we have a very strong support from our current Secretary William Darr, and he says that gene editing is an invaluable technology that can help us achieve food security. So our priority research agenda actually targets climate impacts. So, like, you have heard the expected climate consequences like high temperature, sea level rise, ocean acidification, changed weather patterns, extreme weather events. Like right now we have typhoon, floods, drought, pests, and diseases. And then, of course, we have also signed the Paris Agreement, and therefore we have committed to reduce our carbon footprint in agriculture. For this, we would like to produce these adaptation products that are given here: temperature-tolerant crops, livestock aquaculture species, saline-tolerant, and so on. And, fast-growing and things like that. And also for our mitigation needs, we would like to reduce the carbon footprint. For example, the use of pest-resistant crops instead of using pesticide. Things like that. Also, rapidly growing crops, livestock, and fisheries would reduce the amount of input that you would need to produce a particular food. Okay, and some of the traits that are already edited elsewhere are, would apply, like drought tolerance, fungal disease tolerance, fungal disease resistance, bacterial disease resistance, increased nitrogen use efficiency, early maturing crops, increased grain weight, increased yield, improved growth and productivity, increased grain yield, semi-dwarfism. And these are also the same, most of these, like rice, is the same crop that we're growing in the Philippines. Yeah, and in livestock and fisheries, we have rapid growth, high fillet yield, increased feed conversion ratio. This is the first food animal that is approved. I mean, yes, that has been determined, that is not regulated under their GM regulation in Argentina. It is treated as a conventional strain of tilapia. Then, of course, we have this a number of studies on promoting animal muscle growth in sheep, goat, viral resistance in pig, reduced fat tolerance content in pig, I should say, and resistance to prion propagation in cattle. So these are traits that we could also, what we do usually is to look for the same gene in the varieties that we have and move on from there, do the gene editing from there. So these are the gene editing products in the Philippines. In PhilRice, this is our premier Philippine Rice Research Institute. There is an ongoing project on gene editing in 15 national this NSIC registered indica rice varieties for better grain quality, which would involve lower amylose content and tolerance to diseases like the tungrovirus or the bacterial leaf blight bacteria. That's a bacteria, okay, and also abiotic stresses. So this has been started by our by Dr. Ordonio at PhilRice. At UPLB, we have several ongoing projects also: gene editing in tomato for virus resistance and increased lycopene content, gene editing in eggplant to minimize browning and study the role of the gene in pest resistance, gene editing in rice for drought tolerance. This is in collaboration with the International Rice Research Institute. Gene editing in corn to decrease phytic acid production. Gene editing in banana, targeting the genes that are related to pathogenesis to this Banchitak virus, which is a very devastating disease in banana here in the Philippines. And in the DA Fisheries Biotech Center, we are currently evaluating a proposal on gene editing in tilapia for enhanced muscle production, or, you know, as what they have in Argentina, you have this high yield of fillet. Well, from Erie, there is this rice that they have already developed, which is resistant to bacterial leaf blight. This is already available, and I think they're just waiting that the regulatory system starts operating for gene editing for gene edited crops in the Philippines to request for a determination whether they can release this as a conventional variety or not. So, you know, BLB or bacterial leaf blight causes 20 to 70% yield loss in the Philippines, and this is caused by the bacteria Xanthomonas oryzae. And what they found, you know, you have to study the they studied the molecular mechanism for the development of disease, and they have identified the rice receptor genes that would allow the disease development, and this is what they remove. Okay, so this is now a gene edited product that would be made available very soon. Once we have operate the gene editing regulation that we have, actually currently we are consulting with our stakeholders on the method that we're going to use to determine whether the product is falls under the GM regulation or not. And they're also developing at Erie this rice tungro resistant varieties. This is still on. They're still doing this one. They're still developing it, unlike the bacterial leaf blight resistant rice. Well, of course, our constraint, and probably most of the developing countries like us, we have very few breeders. We have few molecular biologists, fewer facilities, and of course, not all crops are amenable to tissue culture. And let me end my presentation with, again, a quote from our secretary, William Darr, which he presented a paper at an international forum also. Together, let us find ways to extend the benefits of new gene editing technologies across the agriculture sectors of our nations. Thank you very much.
Thank you, Mamina, and for giving us an overview of what is happening in the Philippines, as well as giving us, showing us the opportunities as well as the challenges that are facing our country when it comes to this technology for gene editing. So at this point, I'd like to encourage everyone to send in your comments in the comment section on Facebook or in the question and answer box on Zoom. Carl has already answered some, but we'll, in the interest of, for the sake those joining us from Facebook, I'll read them and perhaps we can have a round of question and answers. So, we'll start now. There was a question here about, I'll just read it from one of our attendees. It is important, in my view, to use the term gene editing rather than genome editing. As you know, every word used in this area is very important, and we need to emphasize the specificity of gene editing versus genome editing, which implies gross changes. So he's asking, what do you think? There is a related question here that the sender feels that misunderstandings are caused by certain lack of global scientific consensus on the definitions and terminology. Are there steps, no matter how convoluted, to resolve this about the term being used? So, Carl?
Yeah, thanks, Jerome. It's a great question, and it's one that I find very frustrating as well, because in fact I've been to a seminar and a gentleman put up the different names and terms used for gene editing, genome editing, and precision breeding. There's about 50 different definitions that are used. The reason that I refer to it as genome editing is because some of the new components of the gene editing toolbox allow you to edit things other than just the gene, right? You can change the structure of the DNA. You can regulate a gene by changing something in the promoter. If you take the polled cattle example of genome editing, they actually do an edit that has got nothing to do with the gene. So, how do you capture those products? The follow-up question is really good as well, because here in Australia, we actually have two main regulators. We have one regulator that focuses on the cultivation or the environmental aspects of a product that's been developed using gene technology. And then we have our food regulator that looks at food safety. They have two different definitions. So that makes it really difficult. So at the moment in Australia, site-directed nuclease 1 form of genome editing is not regulated by our gene tech regulator, but it could be regulated by our food regulator. So that causes an issue here in Australia at the moment. The shining light, though, that I think that we have, and Professor Halos highlighted this in her talk, is the Cartagena protocol, because there are a lot of signatories to that protocol, and it has one definition that everybody has signed up to. And so by using that one definition of what a GMO is, or an LMO, that provides some consistency. So I think that's where we're starting to head, that we will get some consistency in definitions, and that will make it a little bit easier for us to understand.
Thank you, Carl. Ma'am Halos, is it the same in the Philippines? Are these a definition of terms a point of debate or of confusion as well, in your experience?
No, actually, that's why, when I decided to simply use the term gene editing, and then I also made it very specific that you're targeting a gene. Okay, so that's very clear that when you use gene editing, you're targeting a gene. Okay, in our regulation, we talk about whether it is an LMO or not. So that's very, that's also very specific. And there's also a very clear definition of that. So it's not confusing. Well, as far as I'm concerned, it is not confusing. We have not encountered any question about the way we are defining terms, actually.
Thank you, Ma'am Halos. And the next one is from Facebook, from Thelma Soriano. If the gene-edited product is to be regulated, just like what's happening in some countries, the red ones in Carl's presentation, what are the issues to be addressed for effective regulation? So whoever wants to go first. Carl, Ma'am Nina?
I think Carl would. We don't regulate. If it is not LMO, we do not regulate. Okay.
Yeah.
Except that it goes through, like your variety registration and so on. But
yeah. So on the slide that I showed with those countries that were in red, so New Zealand and Europe, the EU, they are very, very clear that the process of gene technology, whether it's using genome editing, gene editing, or creating a genetically modified organism, an LMO, that they are regulated as GMOs. So they have legislation that allows you to seek an assessment of those products, but the challenge is not the assessment and the safety assessment that's done on those products, it's other components of their regulatory system. So if we take New Zealand as an example, you don't have to just submit an application to the regulator to have your product assessed for its safety to the environment or for human health or animal health. You also have to consult with the local Māori and have their input into the assessment. And there is a high level of public interaction. And some of that public interaction leads to and has led to cases going to court. And because of that, that has been where there has been a block. In other jurisdictions, the lack of political will to follow the regulatory systems that are in place has been a roadblock to some of the introduction of some of these products. If we look at what's happening in Europe, there is a lot of groundswell to relook at the definitions and to relook at the regulatory systems of those of the EU in light of genome editing or gene editing. So I think we've got a lot to play out over the next few years, but there have already been some instances and some court rulings that have created uncertainty and have created barriers to the pathway to market for products in those economies. What we are seeing, though, is across Asia, South America, and in Australia and North America, we are seeing the use of the Cartagena Protocol definition opening up opportunities for those countries. And so ultimately what will happen is the EU will become separate because we will find new markets for our products and we will quite happily trade on those products, and our economies will do well, our farmers will do well. The farmers in the economies of Europe and New Zealand will suffer because they will lack the opportunity to use the tools that will make them competitive and provide the benefits that we are seeing for the crops that have already been approved.
Thank you, Carl. There's a question here from Gabby Romero. What would be an example of a gene-edited crop that may be a pest and hence be regulated as a GMO in the US?
Yes, I think I answered that one, and perhaps I wasn't clear in my presentation. So in the US, the regulations there leverage off of whether a plant pest is involved. So if we are using the process of gene technology to create a genetically modified organism or a gene edited product, so part of the process to deliver the gene editing machinery, we've got a number of opportunities. We can use particle bombardment, we can use agrobacterium tumefacients, we can use viral vectors, we can use electroporation, lots of different delivery methods. In the United States, agrobacterium is listed as a plant pest pathogen. And so if you use that as your delivery method for creating your genetically modified product or your gene edited product, it may require regulation. And so a big part of seeking a determination on whether your product requires regulation is whether you've used a plant pest as part of the process. And so that's where that comes into play. Predominantly, if you're making a genetic modification or doing a gene edit, you're not trying to create a pest. You're trying to provide a benefit that tackles an environmental challenge for productivity and sustainability on farm, or you're tackling a consumer trait for human or animal health. So that was my mistake in my presentation, and I apologize for that.
Okay, thanks, Carl. For Dr. Halos from Alex Santos, are there any updates on soil microorganism as inoculant in terms of gene editing for crops application? That's from Alexander Santos from Halos.
Well, I'm not aware of anybody here in the Philippines working on gene editing of inoculants. Actually, they work well as they are. There's a supposedly project in the US about modifying in bacterium so that it can it can also be used as an inoculant in many crops. But I'm not familiar with that.
Thank
So,
you.
so, so Jerome, in Australia and New Zealand, dairy farming, beef production is a very big industry, right? They're big industries. And so that relies heavily on the forage industry, so grasses. And there are a range of grasses, perennial ryegrass in particular, and tall fescue, that are a predominant pasture grass in both Australia and New Zealand. And they often have a symbiosis with a microorganism called an endophyte. And those endophytes can provide some benefits to the plants in terms of increasing persistence and insect resistance, but they also produce some compounds that have a detrimental effect to animals and can lead to animals actually dying. And there have been some famous cases where the feeding of racehorses, very valuable racehorses with perennial ryegrass that was high in an endophyte and a particular metabolite, led to the death of some very valuable animals. So there is work going on to use genome editing to knock out some of the pathways that lead to these detrimental compounds in grasses. And so I think we'll start to see over the next 5 to 10 years the introduction of forage grasses that are animal safe.
Okay, thanks. Now another follow-up question. Another question from Dr. Romero for both Carl and Ma'am Nina. Is there still value in marker-aided or molecular breeding now that gene editing is available? I think this is a good one.
Absolutely. So gene editing, GMOs, they're just one tool in a toolbox of opportunities. And marker-assisted breeding, the combination of the phenotype and the genotype to predict an outcome, is modern breeding. So I'll give you an example. In Australia, every single dairy cow has been genotyped and phenotyped for the last 50 years. And so there is now an algorithm that has been used where you can get a daughter that is born, get the DNA and predict the milking value with very, very high efficiency of that animal before it even reaches maturity to produce milk. So that concept is being applied to plant breeding, where you're speeding up the breeding process by predicting not just the breeding value on what the potential yield might be, but they're also linking that to market value. So a breeding value that incorporates potential in yield and also potential in value. And that's really important.
Yes, I agree with Carl. Actually, you still have a good use for molecular breeding, using molecular markers, because not all the genes have been sequenced yet, and you cannot use gene editing for all of these, but they have been used and they have been shown that these markers are very useful for breeding.
There's one question here by Iyam, what's his name, from Thailand, Imipon Iyam Supasit, and the question is, what is the idea of NGOs on the regulation on genome editing crops, and how can we deal with them if they forced to be regulated? And Carl responded this lengthily, so can you please repeat, Carl?
I have to remember what I said, Ola. Look, one of the big challenges that we have when we're dealing with technology, and we're talking about making changes to the genome specifically, or creating a genetically modified organism, it creates an element of concern with people. And we have to acknowledge that that is a real concern. So in order to address that concern, and actually, in fact, the concern came from scientists first, not from consumers. So many decades ago, the scientists said, look, we have some uncertainty around these biological products that we are developing. So therefore, we will call them and define them as biological hazards, right? Much like a snake or a poisonous plant, or, some sort of microorganism that can cause harm to us or the environment. So let's assess them for their safety. And so through those processes, we have developed international standards and conventions for assessing the safety to us and the environment for products for where there's some uncertainty. But over the last 24 plus years, we have assessed many products and many traits many times, and shown that they are safe for us to eat and that they have actual positive benefits to the environment. Those frameworks that have been developed and implemented to look at that uncertainty exist still today, and products still go through that process.
Mm-hmm.
Gene editing as a new opportunity is what we are looking at as to how those frameworks can look at the potential uncertainty or potential harm of these products. So it's something we have a lot of experience with in terms of how do we know if this is safe? What we do know from the science, no matter how complicated it might be or how big the names or the terms might be, by making a very specific change compared to lots and lots of changes which are done through conventional breeding, it's actually a lot safer. And there's a lot more scrutiny over those products. So if you take plant breeding, let's say we've got a pack of playing cards and we take out all the red cards on that side and we have the black cards on this side. And we can shuffle those, right? So we have the red parent and the black parent. So what if we just want to take one black card and put it into a red deck? We shuffle the cards and we've got a mixture of red and black. And then we have to shuffle that red and black pack with another pack of red cards and keep shuffling it, and then another red pack, and then another red pack. And that's many, many generations to get a red pack with just that one black card in it, the one that we wanted. That's breeding. And so there's been lots of shuffling of genes, which means that the traits get changed. But what if we could just take that pack of red cards and just put one black card in, very, very specifically? That's what we're doing with genome editing. And so I think it's because of that precision and that accuracy, the steps that are done through breeding to ensure that the product meets the requirements for industry. I think we can have a lot of confidence that those products are safe.
I hope Dr. Lam Supasit is heard that. And actually, he is from Thailand. He's one of our people in Thailand. Okay, Jerome is back. So I'll give you back your moderatorship.
The winds blew, and with it took slightly my electricity, our electricity, but it's back now. It's a live show. It happened. So for anyone can answer this one. For poorly sequenced crops like adlai, how can gene editing be useful? I think very important. I think Ma'am Halos mentioned it earlier that there is a need for gene sequencing. How can we benefit from gene editing in such instances?
Yeah, actually, one of the opportunities there is that many of the genes in grasses are similar. They have not changed much. So it's, a gene in rice could also be the same gene. It's the same gene that controls the same trait in adlai or in corn. Or actually, the nearest relative of adlai is actually corn. So you can look, there's many genes that are already sequenced in corn, and we can use that, to identify the genes in the adlai.
The important thing here, Jerome, is not just to do genome editing because you can. There needs to be a real need for it. And I think a message for the audience that I think is really important is that when we're talking about these technologies, we need to talk about them in terms of the product being pulled through because it has a clear, demonstrable benefit to tackling some of the challenges that we face, such as through climate change or human health. So unless the product has some sort of benefit, then there's really no need to do it. And I think if we learn some of the lessons from the past with the introduction of GM crops, often it was seen by the public as being very much a technology push. And that, if you're being forced, having technology forced on you, people will get resistant and they will start to ask questions about what are your motives. So I think we have to consider that, when it comes to some of these technologies, people do feel concern. But what we have to do is look at and focus on those products that really have benefit, and that we allow those products to be pulled through because that tool is the only tool that we can use to deliver that benefit.
Thanks, Darr. Here's a question anyone can answer. Is it safe, or should we think that gene editing leading to GMO creation can be compared to mining, wherein both are doing extraction and later would create pollution or destruction? What are your thoughts?
I think that's an example of concern, Jerome. And, I think that's genuine, that some people do feel that, we're tinkering with things that have perhaps some unintended consequences that we don't know about. But I'll just reiterate that, this is no longer a new technology. We've had it for quite some time. We've got a lot of experience, and we have developed and road tested international practices and guidelines to assess the safety, not just for the environment, but for the food safety of these products. And I think that because of those systems and processes and the way our understanding now, the likelihood of those sorts of mining disasters that people might think of are negligible.
From one of our attendees, considering the logistical issues in performing genetic engineering research here in the third world, may I ask for some insight regarding the role of in silico methods such as metabolic modeling in prototyping and generating potentially viable agribiotech products?
That's a deep question, Jerome.
It is.
It's a very deep question. I think the reality is that, again, genome editing is just a tool, but we have the ability to generate vast amounts of information around the genome, around the phenome, the phenomics, the characterization of the phenotype, the metabolome, all the different metabolites, and characterizing the pathways that lead to these compounds, the proteomics. We can do a lot in silico, and the use of machine learning and all these things, absolutely they will play a role. Absolutely they'll play a role. And they already play a role in some of the food safety assessments and the environmental safety assessments in terms of modeling the introduction of these products. What do they do, the characterization of them from composition through to, modeling them in the field in terms of if you have this amount of area, what's the likelihood that that will form a population that could go rogue and become a weed. So absolutely, there is room for that, but I don't think we're quite there yet.
So thank you for that. One final question in the interest of time. We have been receiving a lot of deep and good questions here. From Albert Karaan to Dr. Halos. Given the constraints that you mentioned in your presentation, there was a slide on that, on constraints. What are the ways that we can do to move forward in the Philippines?
Well, actually, the department is going to establish a network of biotech centers where we can accept scientists from other parts of the country who can come and do the specific techniques that they need to do, of which they do not have any facility to do. So that's one of the things that we are looking into, and also to provide fellowships for these fellow scientists who are in other institutions. So, and we're hoping also to organize networks actually of researchers who would be working on the same project, different aspects of the project, they have different skills, and they're going to use different tools so that we can facilitate the production of new varieties, for example.
So I think that's it for now. Today we were given a preview or an explanation of what gene editing is. And we look at it as a tool, one of the tools in our arsenal that we can use to arrive at the desired products that can potentially create impact or benefit a lot of farmers and farming families. So Carl here gave us a discussion from the global perspective about what is happening on gene editing in different parts of the countries. There are countries that are not regulating. There are countries that are still discussing on what to do with it. And there are countries who do regulate it. On the other hand, Ma'am Nina given us what is happening in the Philippines, the opportunities as well as the constraints and what is happening in gene editing in the Philippines. So for those who were questions that we were unable to answer, we will share them with our speakers later on, and hopefully we can provide, they can give you the questions later on. So before I call on the director, may I request for our speakers for some closing or takeaway messages? Carl?
Thanks, Jerome. I guess the takeaway message is keep asking questions, because they're all very good questions, and we learn through asking questions, and that's the scientific approach. I think we shouldn't fear new technology. But we should ask questions of our scientists, and we should ask questions of our governments to ensure that we maintain the wonderful, safe food that we eat and that we produce. So that would be my main message, Jerome, is that there's nothing wrong with asking the question. Let's keep asking those questions, but be part of the discussion, take an open mind and listen and contribute.
Dare to ask, continue the discussion. How about Ma'am Halos?
Yeah, thank you very much for this opportunity to be able to share our, our thoughts and also what we're doing in the Philippines to other, to all our participants. If you would like to join our consultation, we have consultation on the policy on the determination of whether a product of plant breeding innovations is a GMO or not. We have public consultations, 2 of them this month actually. So for those of you in the Philippines, you may want to join in those consultations. They're usually found, the link could be found in the DA website. Now, I think, we should not stop exploring new methods of improving agriculture, because we are in a different situation today than we are, 100 years ago, because some people would like to say, let's go back 100 years. This is the way we've done it. And but that is no longer the case, because today we are in a different situation, especially climate change. It is changing everything, like, for example, people are saying that we should go back, we should turn, to all these native pigs which are, they have gone through all these changes. But the change in climate is a different one. It has not been experienced by the world since. So I think we should be very open to new technologies that could help us. And we should, of course, be very aware that they could also cause damage, and that is why we have all this regulation. Take note that we have had genetically modified organisms for more than 20 years, and we do not, because of the regulation, and maybe yes, because of the regulation, they are all safe. They have been evaluated for environmental safety, for health safety, and they're all safe because we do have a rational, a science-based regulation that is operating.
Thank you, Ma'am Halo. So to do not stop, to be always open, and to keep moving forward, especially in the different era that we are currently experiencing. Thank you again to our wonderful resource persons, Dr. Carl Ramage from Australia and Dr. Saturnina Halos joining us from the Philippines. Let us give them a virtual round of applause. Maraming salamat po. At this point, may I now call on our director, Dr. Glenn B. Gregorio, for his closing message. Dr. Glenn?
Thank you, Jerome. I'm really, I enjoyed the presentations, and we should put this discussion more. And I hope, actually, when I talk to different people, I use the vaccination because everyone is used with these new terms about RT-PCR. So if I use the RT-PCR, then I start explaining the gene editing and all this GMO. If you have this mRNA about the Moderna and Pfizer and this, you could use those information to jumpstart, because they will be interested on vaccination and all these things. Then you could explain gene editing, you could explain GMO, all those things. So again, thank you all for your nice presentation. And again, I want to greet Mr. Morgan Haas of the USDA Foreign Agricultural Services of American Embassy of the Philippines. Thank you for your presence here. Of course, to Dr. Carl Ramage, thank you very much for your presentation. of course, our very own Dr. Saturnina Halos, the president of the Biotechnology Coalition of the Philippines. I will call it the Biotech in Action of the Philippines. So, of course, you have there Dr. Ola Dermita, the GMO lady of the Philippines and the whole world. And to our colleagues of SEARCA, to all the participants who was with us to learn more about the genome, or we call it the genome editing, whatever, as long as you could lemonize it and explain it to the people. I may say that we need more gen editor now, or genomic editor. So maybe the people from the communication will help us edit our genes here. And thank you for our colleagues, for congratulations for your organizing this SOLVE webinar on gene editing. This is very near my heart. And of course, I would like to commend Dr. Ped Orencio and Jerome Baradas of our research and thought leadership department for leading this initiative and making this advocacy of both SEARCA, ISAA, and USDA a reality, and to solve, and our SOLVE team, or we call it SOLVE, SEARCA online learning and virtual engagement for the support. This topic really is very close to my heart because not only I am a farmer, I'm also a plant breeder and a geneticist by practice. And I recognize the importance of genome, or they call it gene editing application for crops and animals, and need to regulate the framework that are science and evidence-based. I hope there's no more regulation because I know I'm familiar with plant breeding. This is just conventional breeding. We just tweak a little bit and we are not adding anything. So that's the good thing about this. And I'm hopefully we will get rid of this much regulation, and this will be treated like an ordinary variety product of plant breeding. We will not, just like if the golden rice is using gene editing, that it will be released any time within less than a year. So at this point, we can clearly see and appreciate how modern biotechnology as agricultural innovation accelerate transformation. This is really, as I say, a game changer. We are now in the age where plant breeding innovations and cases of genome or gene editing, edited products are highly relevant now and forever and evermore. And we act, as I mentioned, we need gene editors for this one. And this is now my dream before, to have an accurate plant breeding. So it's very accurate, not random.
Very accurate.
So to all our participants, let us use our experience to be the trailblazer for our farmers, to make our farmers transformers. They are transformed mindset and they are more active in making this happen, and the farmers and transformed farmers and farming families. At the same time, the greatest challenge to us now is to spread the word and use the more layman, so that we could benefit the technologies and that could be applicable for our farmers. I believe that the learning from this SOLVE seminar will lead us to a better, bigger, and smarter normal that is highly relevant to the future of the Philippines and the rest of Southeast Asia. So again, in behalf of SEARCA, thank you to our speakers, organizers, and of course to our participants. Stay safe. God bless us all.
Thank you very much, Dr. Glenn, for your words of support and encouragement. Again, gene editing is just one of the many tools that we can use that are available to us in accelerating transformation through agricultural innovation. So do not forget what our speakers encouraged us to do. Don't get tired of asking questions, of being open and moving forward with the technologies that are available to us for a safe and productive farming system of Southeast Asia. Once again, thank you very much. Also to the people in the background, those you don't see during this webinar. It's a whole team effort, and I wish I can share the screen with all of them right now. Thank you very much. Let us help one another get through this COVID-19 pandemic. We hope that as we go along, we will be able to create a community of, as the director mentioned, better, bigger, and smarter farmers and farming communities. On behalf of the organizers, SEARCA, ISAA, and USDA FAS, we thank you for joining us. This is Jerome Baradas. Have a good day. Stay healthy. Stay safe. Goodbye, everyone. Join us again next time.